Okay, so looking at solving some of these congruences, the first one that was asked about was this 9x is congruent to 2 mod 16. I'm still not sure why they put the m equals 16 on there, because that's clearly mod 16. Okay? I don't know. Anyway, to the task at hand. So, the first step in any of this stuff is to figure out, okay, well, what's the greatest common divisor? So the greatest common divisor for 9 and 16 is 1. Okay, now this actually means I've got actually two different ways I could solve this. So I'm going to go through both of them just to give you an example of both ways. If the greatest common divisor is 1, that means 9 has an inverse mod 16. Okay, and you could just go through and say, okay, well, 9 times what equals 16? So you go, okay, well, 9 times 1 is 9, and I'm mod 16 in all of this. Okay, 9 times 2 would be what? 2 mod 16. Okay, because it's 18. Oh, that actually gave me the answer right there. Just trial and error. Okay, because that's what I was looking for. 9 times what? Okay, um, so a basic guess and check got it really quickly, and sometimes that happens. But let's just go on just to show you what I'm talking about. Say, okay, well, 9 times 3 then would be 11. 9 times 4 would be 4. 9 times 5 would be, what, 13 mod 16. 9 times 6 would be 6. 1, right? 9 times 7 would be 15. 9 times 8 would be 8. 9 times 9 would be 1. Okay, so what this tells me is that 9 is its own inverse. Okay, back up on this equation then, or this congruence. Okay? I can multiply both sides of this by the inverse of 9. So if I have 9x congruent to 2 mod 16, okay, I could take that and go, okay, well, let's multiply this side by 9 and let's multiply this side by 9. Okay? And if I do that, I get 1x, because we just discovered 9 times 1 is, or 9 times 9 is 1, and then that would be 18 mod 16, and then when I reduce that, we're going to get 2 mod 16. Okay, x is equal to 2. Okay, so that's one way to do it. Okay, now let me do it a different way here. Oh, and I'll need, well, that should be enough room. Okay, so the next way to do it is to write the greatest common divisor as a linear combination. And the way I always do that is I use the Euclidean algorithm. Okay, and I would start off and say, okay, well, 9 or 16 is 9 times 1 plus 7, right? And then 9 equals 7 times 1 plus 2. So keep in mind, each step of the way, I'm always starting off with the two numbers and using the division algorithm, right? We're writing it with quotient remainder. Then the old quotient becomes the divisor. The remainder becomes the new quotient, right? Each step of the way. Okay. Now uh, now we're going to have the 7 here and then the 2 on this side, all right? So it's going to be 7 equals 2 times 3 plus 1. And then, of course, then 2 equals 1 times 2 plus 0. And the last non-zero remainder is our greatest common divisor, right? So our greatest common divisor is this. Now, I can take this and work backwards, okay, to find out then what a linear combination is. So start with that line with the greatest common divisor and get the 1 by itself. So that's going to be 7 minus 2 times 3. Okay. Then I look at the next line and go, okay, well, the next line, I look at this remainder, okay, and I am going to write that as 9 minus 7 times 1, but I'm going to make that substitution in for the 2 here. I'm going to write the 3 in front, okay? It's going to be 9 minus 7 times 1. And, of course, this was 7 times 1 as well. So 7 times 1 minus 3 times 9 minus 7 times 1. Okay. So that would be plus 7 times 1, right? Because minus the negative. So that would be 7 times 2. I'm just collecting my like terms. Minus 3 times 9. Now I go make the next substitution. Look at the 7. Okay. So 2 times 16 minus 9 times 1 minus 3 times the 9. Let's see, that's 2 times the 16 minus 2 times the 9 minus the 3 times the 9. And let me check and make sure I haven't goofed something up, because something doesn't look right to me. Yeah, and I've messed something up here. So, times... Oh, I can't multiply 3, apparently. Oh, my goodness. Okay. Well, that did not equal 1, so I knew I screwed something up, because that would be 21 for, well, 3 times 7. Hold on, what did I mess up? No, I'm going to... All right. 7 minus 2 times 3. Now let me make sure I did all that. 7, 8, 9, 7, 6, 7. Okay. All right, so 1 is 7 minus 2 times 3. Now the 2, 9 minus 7 times 1. So that would be 7 minus 3 times 9 plus 3 times 7. So that's 4, 3 times 9. Okay. Now the 7, you make the substitution for 16 minus 9 times 1. That's got it right. All right. So there's a linear combination. The greatest common divisor written as a linear combination. Okay. All right. So I need this to equal 2. So I'm going to multiply both sides of this by 2. Okay. But really, I'm going to only multiply those coefficients. Okay. So this is 2 equals 8 times 16 minus 14 times 9. Feeding off of this, then, if I write this as um, that we have 9 times a negative 14 will be congruent to 2 mod 16. Okay, so your modulus, here we're kind of dividing by the 16, right? So I know that's the modulus here. And then whatever the coefficient is for x, for 9, in this case, because it was 9x, this would be your x. So from that, then, I get my x is congruent to negative 14 mod 16. But then negative 14, of course, is just 2 mod 16. Okay. So that gives me another way to solve that one. All right, so let's look at some of these other ones. And it wants us to find all of them. Okay. So I'm just going to look at like A. Okay. Let's see. Yeah, let's just look at A. So 5x can go into 3 mod 6. Okay, so again, I'm going to look at the greatest common divisor. Okay, what's the greatest common divisor for 5 and 6? Okay, well, looking at it, I know that's going to equal 1. Okay, it's going to be 6 equals 5 times 1 plus 1. 5 equals 1 times 5 plus 0. So 1's that. My linear combination would be 6 times 1 minus 5 times 1, right? Or plus 5 times negative 1, however you want to write that. Okay. Now this needs to be equal to 3. Okay. So multiplying both sides by 3. 3 congruent, or, equal to 3 times 6 plus negative 3 times 5. So that means my 5, the x is going to be 3. Okay? So my x is going to go into negative 3 mod 5. I'm sorry, mod 6. Okay? And that is going to be then 3. So x is going to be congruent to 3. Okay? Now, since the GCD was just 1, that is going to be a unique solution. Okay? Now, if you want to verify that, you can always look at things like kind of long way. This one wouldn't be all that bad, right? 5 times 1 is 5. That's not going to work. 5 times 2 is 4 mod 6. 5 times 3 is 15. 15 mod 6 would be 3. That works. 5 times 4 would be 20. And 20 mod 6 would be 2. 5 times 5 would be 7, would be 1. And then when you get to 6, that should be, of course, 0. And then everything would start over again. You can see there's only one of them that has that solution. And that'll happen anytime that the GCD is 1. So that's going to happen on all of these, okay, on this one, on this set. So how about this one? Okay, so let's look at A. 12x growing to 18 mod 15. Okay. And we want to find the GCD, so the GCD, I believe, is going to be 3 for the 12 and the 15. Okay, so that's what we're looking at. We're looking at 12 and 15. What's the GCD? That's going to be 3. Okay. And I'm going to write that as a linear combination. So I'm going to do this the same way each time. Okay, so 15 is equal to 12 times 1 plus 3. Okay. 12, oh well, this is going to be kind of a boring linear combination. 3 times 4 plus 0, so there we go. So our linear combination then, 3 is my greatest common divisor, is 15 plus the negative 1 times 12. Okay. So my x to start with is going to be negative 1, which of course is congruent to 14 mod 15. Okay. So that's my first solution. Okay. Now I got to figure out, okay, what is the next set of solutions for it? Okay. And if we do the modulus divided by the GCD, okay, so I'm going to call that K. 15 divided by 3 would be 5. As long as I go in increments of 5, I'm going to have another solution to this. Okay, so I start off with 14. My next one is going to be 14 plus 5. Okay, so I'm going to make that list down here. So that would be 19. So that should be 4. And we could check it each step of the way, right? If you do 12 times 4, that's 48. Mod 15 Okay, and that gets you 3. Okay, which is what it should have been anyway, right? Because I could reduce this to 3. That's 3 mod 15. Doesn't matter whether you do or not, but so it works. And then add another increment of 5. So do 5 times 2, so that'd be 24. And then 24 mod 15 would be 9. And add another increment of 5. Okay? If I do 14 plus 5 times 3, okay? Let's see, 9, that would be 14 again. We're right back to the beginning, and we have the 3 solutions that we knew we were going to wind up with. Okay, so those are going to be all of them, because it starts repeating after that. So we can do another. Let's do C. 10x is congruent to 14 mod 18. Okay. So 10x congruent to 14 mod 18. Okay. So 18 is 10 times 1 plus 8. Okay. 10 is 8 times 1 plus 2. Okay. Is 2 times 4 plus 0. So my greatest common divisor is 2. Okay. It tells me I'm going to have 2 solutions, right? Okay. So CD, so that tells me then that there are 2 solutions, and also that to get the multiple solutions, we take 18 over 2 would be 9. We're going to go in increments of 9 once we find the first one. Okay? So to find the first one, I'm going to rewrite that as 2 equals 10 minus 8 times 1. And then I go back up and I look and say, okay, well, look at that remainder. And that's what we want to substitute in for the 8 here, right? Okay. So that's 2 equals 10 minus, and I'm going to call that plus a negative 1. Okay. Then the 8 is 18 minus 10 times 1. So I'm going to distribute. So that's a negative 1 times 18 plus 10. All right. So now there's 2 of those. So 2 times 10 plus the negative 1 times the 18. Okay. And that does equal our 2. Okay. So now we need that to be equal to 14, not just 2. So I'm going to multiply both sides by 7. Okay. That's going to be 14 is, let's see, 14 times 10 plus negative 7 times 18. And I always check stuff, when I can. So this tells me my first solution, then my modulus was 18, and it was 10 times something. Okay. So the 10 times 14, that is my first solution. So x is going to 14 at 18, which is 14, right? Now if I want the next ones, then if I call that x1, then x2 is going to be 14 plus 9. I'm getting that from the 9 I found over here. Okay. So 14 plus 9 would be, 23. Mod 18 would be 5. And shoot, check it each time of the way. 5 times 10 is 50. What is 50 mod 18? Okay. That would be 14. And then x3, we're going to add 9 again. And I just always add it to the previous one, really. So I'm just going to do a plus 9 there. And that yellow was really kind of hard to see, at least with my eyeballs. Okay. So I'm just going to add another 9. And lo and behold, let's see, that comes up with 14. And I always do that one more step just because it should be the same as the first one. I know I've got two solutions. So it should just have been the 14 and the 5. When I add 9 again, it should cycle back to that 14. Okay? And if it doesn't, that just tells me I've done something wrong. Okay, I hope this helps a little bit. And if I can clear it up some more, please let me know.